Well, welcome, ladies and gentlemen. What I'd like to do is show you how to solve this compound inequality. And what we have is 1/2 x is less than 3, and 5x is greater than or equal to 10. And since we know that it's and, we know that both of these solutions, the graph of our solutions are going to intersect because it has to be true for both of these. Our solution has to be true for one and the other. So first of all, though, let's figure out what exactly are our solutions. So we need to solve for x. So you can see here I have 1/2 times x. So to undo that, I can multiply by the reciprocal on both sides. Now, any number multiplied by reciprocal equals to 1. So now that's equal to x. And then here you can rewrite that as over 1. So then x is less than 6. And here I just undo multiplying by 5 by dividing. So I have x is greater than or equal to 10 divided by 5 is 2. So now I need to graph my solution. And I need to make sure my number line is going to at least contain the points 2 and 6. So I'll go to 0, 1, 2, 3, 4, 5, 6, 7. OK, and let's do -1. So now all I simply do is put points at 6 and 2. But when I'm making points, I want to make sure they're going to be open. All right? Then I only close them. That means fill them in when it's greater than or equal to, or less than or equal to. Pretty much look for that line. See, that one has a line, so therefore I know it's a part of my solution. Here I do not have a line, so therefore it's not a part of my solution. Now the next thing is I'm going to show you how to do it without kind of using your test points. I'm just going to kind of read it out loud, and let's think about it. All the solutions that make this true are all the numbers that are less than 6. So all numbers that are less than 6. Can it equal 6? Is 6 less than 6? No. Is 5, 4, 3? Yes. So it's pretty much going to be all solutions that are less than 6. Is 7 less than 6? No. So any numbers to the right of this is going to be false. Then we go ahead and graph this one. All numbers that are greater than or equal to 2. Well, since you can see why if it's 2, it's part of the solution. But all numbers that are greater than. 1 and 0 are less than 2. So it'd be all numbers that are greater than. So you can see that, remember, when we're talking about and, we're talking about the intersection, right? Where do these two graphs intersect? Well, and they also have to be true for both of them. So at 2, they're true for both of them. That's why we graphed that there. For 3, for 4, for 5. So for all these values, they're true for both equations. However, at 6, it's true for this inequality, but it's not true for this inequality. That's why we leave that open. So when graphing a compound inequality with and, make sure that you're dealing with the intersection of both inequalities. You go ahead and solve, and then graph them on the same axis. Thanks.